Okay, welcome back. In this video, we will start to talk about version control. Especially, we will cover the basics of the Git version control software. In order to do so, we will start to develop a project in this video, which we will do over multiple sessions. Basically, let's say a bigger programming project, a programming package, which we will call LinSolver, and this program package should be just responsible to solve a linear system of equations using the Gauss elimination method or LU decomposition. Our project will have some I/O, so communicate with the user via console or via files, basically reading in the matrices which represent the linear system of equation and writing out the result. We will of course make sure that we are setting up a nice automatic test framework to make sure that we can test our package or library on functionality, and especially we can also refactor code and change algorithms behind the code and still make sure that our code works as supposed. Of course, we will document our project properly. That means we will have user documentation and developer documentation. We will also extract developer documentation automatically from the code. And of course, we will also make sure that all the things which we have learned so far about Python are applied so that we have a cleanly written, nice code. A disclaimer I would like to emphasize is this project is just for didactical purposes. If you want to do real science and in a production code you want to solve a linear system of equations, make sure that you are using the SciPy module, which are specialized for those purposes and much faster and much more efficient than the one we are programming here in Python. Okay. I will basically, so let's start develop, and I will now demonstrate things here on the screen so that you can type with me. Basically, I already launched a console. You should also do either your Git bash console or your terminal if you are on Linux or Mac, and make sure that you are also already started and initialize your Conda environment with and the status the SciPro environment within Conda, right? And we will just create a directory for our project. So I'm in when you start your terminal, you are in your home directory in your user folder, and with mkdir I can create a directory, make directory, and I will just call this directory SciPro, and I'm just hitting enter, and then it created a directory. With cd change directory, I can change into this directory, and I will just write cd SciPro and just enter. And by doing ls, I can even list the files which are in this folder. There is not much in this folder yet. Of course, the folder is empty. We just created it. I will also create a subfolder within SciPro, which will be our LinSolver project. So I'm saying just mkdir LinSolver. Now, if I'm doing ls in the SciPro folder, then you see that basically here there is a directory LinSolver which had been created, and I will just basically change into this LinSolver directory by cd. And you see I typed it very fast because I just only type the first two letters of the LinSolver and then push the tab button, and it will be automatically expanded. So this is something you can use under Linux or in this command shells very nicely. And then hitting enter, we are now in the SciPro LinSolver folder. This is what I wanted to do. By the way, if you want to leave this folder, you want to go up in the hierarchy, that would be the cd ... command. So if you enter that, then you see that I'm back again in the SciPro folder. But this is not what I want. I want to go back to the LinSolver folder now. Okay. So we have our project. Now we will put two files into this project. These two files, solvers.py and testsolvers.py, you can download from the website. I already downloaded it, so I will just copy it from my from the position from the folder where I already stored them. You can use also a graphical tool in order to put those files into this folder. You don't have to use the cp command. The important thing is that at the end in the LinSolver project you have the two files from the website, the solvers.py and the testsolvers.py files. Okay. We will visit this file using Visual Studio Code, which you already have also downloaded according to the instructions. And in order to start Visual Studio Code, I will just type the command code and pass an extra argument, which is dot, which means the current directory, which means Visual Studio Code is started and uses the current directory as a project, which will be automatically open in Visual Studio Code. If we do that, Visual Studio Code starts. It might look a little bit different for you. Mine is already configured to my liking, but it should be very similar also in your case. Now, if you want to open a file, you can just, for example, use the Control O command, like open a file. Then a file browser appears, and you can open a file. Or even better, it even says here, go to file. You can use the go to file command Control P in order to open a file. So I will just do that. I'm just pressing Control P. Then here something appears where I can type in the name of the file. And for example, I just started to type solve, and there are two files which are matching, which have these letters in their name, solvers.p and testsolver.p. I will just open both of them, right? So I will just open testsolvers.p as well. Good. What do I have here? The testsolvers.p is a simple tester, basically. So I have a main routine and which calls just 3 different tests, and each of the tests sets up matrices, for example A and B, the 2 matrices of the linear system of equations, and then it also declares what is the expected result X, which one should become obtained back. And then basically it calls the Gaussian eliminate routine from the solvers module, which we will have a quick look in a second, and stores the result in the variable xGauss. And then it calls here a function check result, which just passed the expected and the obtained result. And this check result, as you can here see down there, it's very simple. It doesn't do anything else. Just print out the expected and the obtained results so that you can visually inspect it on the screen whether you get the results which you were supposed to. Of course, we will automate it later so that it's done everything automatically so that you don't have to watch it, but Python checks for you whether the matrices matches as they should. Okay, as you see, it uses the solvers module. The solvers module is this file. And in this file, in the solvers module, we have only one routine, the Gaussian eliminate routine defined, which takes A and B, so basically two variables, and returns two ND arrays, and returns another array that would be the solution of the linear system of equation. But at the moment, you see that the implementation is very, very trivial. Basically, we are just creating the solution vector with the right shape, filling it up with zeros, and then returning it, right? So it's not very useful, but at least this is something which can be run and already tested. So let's go back to the test solvers, and then we will run the test. Before we do so, you should select the Python interpreter, and as you could see at the opening page, if you are pushing Control Shift and P, then you open the so-called command palette. So basically you have here all the commands, and I would like to select the Python interpreter. So I can just start typing, and then you already have it, Python select interpreter. I'm just selecting it, and it already selected the right one, the SciPro one, which is coming from my Conda environment. So basically I am selecting this one so that it will make sure that whatever it does, it will run in the Conda environment, which I set up here in this SciPro Conda environment. Now let us run this code. So you are pushing here this run Python file button, and then a terminal should open, and in the terminal down there, as you can see, that the result of the test is shown. And of course, the 3 tests have been carried out. Here is always the expected results, and of course the obtained result is always 0, so it's definitely not the same as it should be. So basically our task is now to start and code and install and implement all the things so that we can we get test results which are matching. That's basically the goal. Maybe one more thing about the project itself, or how to run the Python file, and that's that I wanted to show you here. So you can also run the test over outside of Visual Studio Code, of course. You just go into the folder of your project, and then you are just invoking Python 3 and the name of the file you want to run, Python 3 testsolvers.py. If you're using Windows and Conda, it could be that your Python interpreter is called Python and not Python 3. On Linux, in my version, it's called Python 3. If I'm executing Python 3 test servers.p, I get exactly the same results. It's run in the Conda environment, in a SciPro Conda environment, because I set it up here in this window, and I get the same results as before. So basically the expected and the obtained are definitely differing. So we definitely have to work on this project. And this is what we were going to do. But first we would have to learn how to set up Git for the project. Okay, now that we have created our project, let's put it under version control. First, maybe a few words about version control itself. Which kind of scenario could it be useful for us? One of the scenarios would be that, for example, we are starting a project, let's say our LinSolver project. We are just implementing a solver for linear system of equations, and it seems to work. We have kind of tested it, and now we are even uploaded it somewhere, and people are using it and are happy about that. Then we decide to add some new functionality or rewrite some old functionality, and after adding a lot of codes and developing for a while, we suddenly realize that results which were working, or systems which were working before, are not giving the right results anymore. And then if we have added a lot of things before noting that, although that means we have to say that our test system is not perfect, then of course the question is, okay, where did we introduce the error? And then if we don't have any history, then basically we have tried to look up through our entire project and try to find out where the error is. However, if we were basically making snapshots of our project during time development, so basically whenever we added something small, something on its own, then we made a snapshot from that, then we can just go back by history, and usually history is basically starting from down going to the up. So we know that our Git version was still working, or project was still working here. We know that it was still working here. We know that it doesn't work here anymore. And then we can just look in the intermediate stage, go back in time, look at the stage of the project here. No, it doesn't work. Looking here. No, it doesn't work here. Going even back more. Okay, here it works. So basically the only thing we have to investigate in order to find the bug, in order to find out where the bug happened, is just the difference between the last working and the first non-working version. And of course, that can help us to speed up the debugging procedure a lot. And then, of course, when we have found the bug here, we can just fix it, and then basically fix it in the most recent version and add a new version with the fix, which works again. So basically, we have a working version again. Okay. Now about version control maybe itself, basically there are three different things, or several things, but three very important things version control can do for us. The one which we just mentioned, that basically it can store history so that we can go back and visit the earlier stage of the project. But it can also help us to coordinate the development if a project is developed by more than one person. We will talk about that later more in detail. And also it can help us to coordinate the development of a project if the project has multiple different versions via branches. This is also something we will have a more detailed look in the future. Just maybe very quickly, I would like to mention that there are two different version control types of model. The so-called centralized version control system, where Subversion is a prominent and still used software for that, where basically you need a central infrastructure, a central server where you store all the history, and basically the developers have to access the central server in order to browse the history. And there are the so-called distributed version control systems, which kind of took over in the last the 2 decades. And of course, Git is maybe the most popular one. A few projects maybe might still use the Mercurial version control system. And basically here, every developer has a copy of the entire history. So basically most operations you do not require network control or network access. That basically the network connection only needs for synchronization when you are basically try to synchronize your project with other persons. Okay, Now let's start Git and put our project under Git, and I will just do it basically here in the window, basically the commands which you are seeing here. So we are in the SciPro linsolver module, and then we will just make a global configuration of Git. Global configuration means that a configuration which will be valid for all projects from now on when you create new projects. And the first thing I have to specify is my user, that the name of the person who is who is working here, because Git will store not just snapshots of your project, but also some additional meta information like the programmer's name who was committing this snapshot, as well as its email address, right? So we are configuring the username, and we are configuring the user email. And that should be, of course, your email address. So this is my email address. I'm just typing that one in. And then I'm specifying some tools for Git, also globally, because we will use in all the projects which we are doing. And one very important is a so-called editor. This is the editor which pops up if you are writing so-called log messages, which we will have a look at in a sec. In Git, it should be a text editor. If you are on Windows, you can just use Notepad, because that comes with Windows. If you are on Mac OS and you don't know any other editor, a text editor which you can handle, then you can use Nano. Also under Linux you can use Nano, or you can also use gedit if you are in a GNOME environment, or Kate if you are in KDE, or Featherpad if you are under Ubuntu, and so on and so on. So check a text editor, you know, or you can use Vim or Emacs if you know those, but they're a little bit more difficult to handle, so only choose them if you really know what you are doing. So we are selecting our editor, and we are selecting a graphical diff tool. We will later see what is it good for. At the moment we just set it up, so we are saying git global config global, and then the diff.tool. Here in the instructions I have shown you how to install MELD, so you can just set up the MELD tool. If you have under for example KDE, and you have the KD free tool, it's also a very nice one. You can also select that one. For the purpose of the exercise here, I will just use MELD. Important that the ---- global options make sure that the settings are stored also for future repositories which we will create. You can say git config --list in order to list up the configurations you have done, but actually you can also visit them directly, because these configurations are stored in a file, and they are stored in the file in your home directory, a file which is called .git config, and if you look it up you see that here are all the settings you have made. Okay. Now we have everything set up globally Git, and now we are just creating a Git repository or a Git controlled project from our linsolver project by just saying Git init. Depending on the Git version you are using, you might obtain a hint, a warning that here master was used as name for the main branch from the main history line for your project. And this is not necessarily common anymore. Many projects use main, and Git also tells you how you can rename the master into main by saying git branch -m and the name you would like to use instead of master, and this is I will actually do. So I will just rename my branch to main, so just to do git branch -m main if you obtained this hint. If not, then probably you have using a newer Git version and it had been named main already. Actually, Git also tells you how you can set up globally that when you create a new Git repository, that the default branch, so-called default branch, will be named how you like by using a git config option again. And I will just set it up just to make sure that any further projects will use the right name. So carrying this out. Okay. The important thing which we can see it apart of this hint is that Git was initialized an empty Git repository in the linsolver directory, and in a subdirectory calling .git. Now if you are making ls in order to list the files, you don't see it because this directory name starts with a dot, and those are so-called hidden names. So you have to use ls -a. -a would show you all the files which are in the directory, also those which are starting with dot. And you see here that there is a .git directory, and basically this directory contains everything which Git knows about your project. If you delete this directory, basically the entire Git history is gone. On the other hand, if you just distribute the linsolver directory with the .git subdirectory together, then you can distribute your project, including its development history, which can be very, very practical. Now let's ask Git what it knows about our project, and that you do by typing git status, and basically it tells you, okay, we are on the main branch, we have not made any commits yet. There are two files here, solvers.py and testsolvers.py. So far so good, but they are so-called untracked files, right? So basically Git doesn't know what to do with them, they are not tracked. In order to track them, we have to add them to Git's attention, and this is called git add, and I'm just adding the two files solvers.py and testsolvers.py. So, and now if I'm making git status, then you see that I have two files, solvers.py and testsolvers.py, and Git are aware of them. They are not stored yet in the database because it says changes to be committed. So basically when I make a so-called commit means that pushing the files into the database, then those two files in the status that they are now, when I made the snapshot with git add, will be written in the database. So basically git add makes a picture of the files and puts them aside. And once you commit them, those pictures of your files, those photos of your files will be written into the database. Okay, there's one thing I wanted to show you here. Let's execute once more our testsolvers.py script, and of course our tests are still all failing because the expected results is not equal with the obtained result. But if I run it, then Python creates a PyCache directory, and this is something which will be always created by Python if we run the project. And if we are now asking Git what Git thinks about this repository, you see that there is an additional file, PyCache, which is untracked. And this is something I do not want to, and you definitely should not add to the repository, because this is automatically generated with Python. It has nothing to do with the source code which you have written. So we would like to tell Git to ignore that, and this is exactly what I'm going to do. I am just creating a file .gitignore in the linsolver folder, and in this gitignore file I'm just adding the name PyCache, so $PyCache. I'm just storing this file, and I'm just quitting the editor. And now if I'm doing git status, then what happened is that the PyCache, it doesn't complain about the PyCache folder anymore because it's in the ignore file. Of course, I have now a new file in the repository, in the working directory, which is gitignore, which is not tracked yet, but this is something I would like to save into the database. So I will just say git add .gitignore, and now if I'm checking the status, then I have 3 files which I made, so to say, a picture about, and then basically I can commit them to the database. How to commit them? This is the command commit, so git commit, and if I'm just opening git commit, then basically the editor which I specified will be opened. It will tell me that it's an initial commit. It tells me which files had been saved to the so-called stage area, so from which did I do a snapshot, and those will be now written to the database. And here I have to add a log message, and because this is the first message, the first commit, I will just write, okay, this is the initial commit, or this commit will kick off the project. So I will just give the kick off project, I save it, and then leave my editor. And then you see that Git says that 3 files had been changed, with no only lines had been added, no lines had been removed, and those are the 3 files. And if we are now executing a git status, you will see that basically this is here empty. So basically I am on the branch main, but nothing to commit, the working tree clean. What does it mean? That means that the files are in the same shape as, or they have the same content as stored in the database. So basically the Git repository, the database, the last state you store in the database, and the files in the working tree, in the working directory, are identical. So how can I check what I have checked in, what I have committed, how to check the history? And this is the git log command. And if you invoke git log, the result, which the history can be very long over time, goes to a so-called pager. This pager is it's called less for me, and you see that here the special characters which are supposed to handle the colors are not very well represented. Therefore, I will edit the .git config file and just add one line to make sure that this pager, so-called pager, which shows you the results page by page, is handled correctly. So I will say pager is equal less, and with the option minus capital R, which makes sure that less is handling the color correctly. And now if I'm doing git log again, and you see that's much nicer. Now I have the colored output with the right rendering. So what do I see in this colored output? Basically, I see here my name and my email address as the author of the last commit. I see the date when the last commit was done, so it's always stamped with the actual time so that we know when it was committed. I have here the log message. I can see that this is the last commit on the main branch. Head is always the last commit in the so-called current branch, and there is a commit ID. Basically, this is a checksum which uniquely identifies the commit itself. This is a so-called hash checksum. You can use that to refer to a certain commit. Of course, nobody would really type such a long name here. And the good thing is that you can just type, if you want to refer to a commit, you can just the first few characters from this hash sum, because as long as it's unique, everything is fine. Okay. You can also add the option --1 line when you are invoking git log. And then basically you get only just a very short summary with here just the abbreviated commit ID which you can use, and the log message. This is quite handy if you want to do a quick overview about things. If you have multiple commits, then you would get the commits in reverse time order. And as I already told you, always a pager is included so that you use them page by page. And basically you can go up and down with page up and page down. In this pager, of course, I have here now only one entry, so it's not that spectacular. But more important, you can leave the pager by pushing the button Q on your keyboard, right? So that would leave the pager. And with that, basically, we managed to create the first snapshots, and we managed to learn how to add basically different snapshots, different pictures of our project to the database. Maybe I would like just to give you the slides are showing the same again, but what I would like to show you is basically the Git workflow, just to reiterate what we did. So first we were just using git config -- global to set up our Git data, and this is something you do only once on your operating system. Then for every project you start, you make once a git init in order to make sure in the project directory, in order to make sure that Git is creating its database. And then in the project directory, you basically always do the same cycles. That means you are editing some files, then you are basically making a picture of your files. So basically you are just staging them. That means from the working directory, you take the file in the status it is at the moment, and you pack it onto the so-called stage area. And then when you have collected everything on the stage, which you want to write into the database, then you are doing a git commit, and the git commit will write the files from the stage into the repository, right? So this is the next one. And then you start again editing files, adding the changes with git add, the files which you change and you want to put into the snapshot with git add, and then with commit. Of course, if you have many files which are under version control, and you want to git say, just put all the files to the stage area which I have changed and which are already under version control, then there is a magic option -u -updated for git add, and that would put all the files which we changed from the working directory to the stage area. And then after git add -u, you can just make a git commit in order to write them into the repository. Okay. And finally, a few remarks about Git before we finish with this lecture here. So first of all, the big question is, when should I commit? And basically, you should always make a Git commit if implementation of a certain, hopefully small feature has finished. So it's a good idea to have only commits which are all functional, because then it helps you a lot to find bugs. So you should not commit something which is completely half-baked, but you should make sure that the changes between commits are small, to make sure that if you have to find errors in the diffs, in the differences between two stages, it's as easy as possible. The log message you do should be meaningful, right? Because it's the only thing for you to find out what a certain commit is supposed to do. If you don't want to check it out, so you don't want to visit it. So basically, make sure that your log message is fine. And as I already told you, that the changes between commits should be small enough that the developer, you or somebody else, can easily follow and understand them. Okay, so do not make commits which have changes of several thousand of lines. They are basically almost impossible to follow. In order to have good sentences, good log messages, it's a good practice to have first a short sentence, which is 50 or 60 characters long. And then if the commit needs some more description, then just here make an empty line and add some additional description. This is quite common in the Git version control project. And you should stick to that. And if you want to have a good description about suggestions how to write a Git commit message, for example, this link is very useful and demonstrates why proper Git log messages are important. And the last thing I wanted to show you is that if you just want to commit something and the Git message is just a one-liner, then instead of letting Git to pop up an editor, you can also pass the option -m, m stands for message, and then add the message as a string, and then Git will automatically create the commit with that log message, and then check it in. Okay, and with that, basically, you are now ready to start to develop your project and make the first commits to record history. And the next time we will have a look at that, how we can do further, more involved things with Git, and especially how we can go back in history and visit the previous stages of your project. Have fun!